training, image segmentation, and movement detection.
Thank you for the introduction. So today I'm going to talk about pre-processing for automatic cervical cancer screening, image segmentation, and movement detection. So first, an outline of my presentation. I will introduce you the background and the project goals. Then I will cover the region of interest detection. Then I will move to the movement detection, and finally the conclusions. So regarding the background, cervical cancer is a popular disease among women, and it is difficult to detect, especially in countries where the resources are limited. So the World Health Organization recommends two types of tests: the human papillomavirus testing and also the visual inspection with acetic acid technique. So at EPFL, where I was developing this project, we are working on a solution to automatically detect this disease using videos from the visual inspection with acetic acid. So here is the pipeline of our project. First, we obtain the videos using a smartphone. Then these videos are cropped around the cervix and stabilized for later be classified with a neural network and also detect if they are positive or negative and the lesion region. So here we have two pre-processing steps that at the initial phase of the project were done manually. We had to crop the videos around the cervix and also discard the videos having a lot of movement because the later classifier cannot deal with that. So the two main goals of my research were to automatically segment the region of interest and then detect the videos with a strong movement. So for the first part, the region of interest detection, I use the You Only Look Once network. It's an object detection network that works in real time. So it's computationally very fast. And we use the nano architecture, which enables us to put the solution in a smartphone. So how does YOLO work briefly? Well, the image is divided into an S by S grid. And then for each cell of the grid, we predict B bounding boxes and C class probabilities. Then this information is mixed together to compute class-specific confidence scores. And finally, from all the bounding boxes that we predict, we need to take only the relevant ones. And this is done with a confidence threshold and also the non-max suppression. So we trained YOLO using a data set of 650 images. We used 70% of the data for training, 20% for validation, and 10 for the test. And we did cross-validation with 9 folds. Here you can see an example of the annotation. In pink, we have the annotated bounding box around the cervix. We also did data augmentation to make the network more robust to illumination changes and also rotation, scaling, and etc. And we achieved pretty good results, almost a 1 accuracy, almost a 1 precision and recall, and also a really high rise, meaning that the predicted bounding boxes were really accurate to the actual ground truth. And we were able to see also that YOLO even detected the cervix in pictures having a lot of blood, blurry, or mucus or low light. These pictures were initially discarded for being bad quality images, but at the end, we also used them to see which results we obtained. And we saw that YOLO was able to detect this type of, the cervix in this type of image. So how do we get from the frame-by-frame detection to the final cropped videos? Well, we had to generalize the bounding boxes because in each frame, the bounding box is a different size. So we searched for the biggest height and width, and then we centered this rectangle in all the predicted bounding boxes to later crop the videos. And when no detection was done by YOLO, we did a linear interpolation between the neighboring frames. Here you can see an example. On the left, we have the predicted bounding box and on the right, the video already cropped. But not all the videos work really well, because when we have a lot of movement, there are frames that are not detected, as you can see in this video. So we want to detect this type of videos to remove them, because we cannot evaluate the final classification in this type of videos. So how do we do this? Well, we use the bounding box information predicted by YOLO to create a heat map of all the bounding boxes, and then we did a histogram of this heat map. Here you can see that we have two peaks. The black background represents the first peak, and then we have the other peak in here, which represents the white rectangle that is like the perfect overlap of all the bounding boxes. So the rest in between pixels of the histogram represent the movement pixels, and we wanted to quantify this. So we set this metric, this movement score, and then we tried to separate the two types of videos into two categories. So we did the box plots, and we actually saw that using a 0.55 threshold, we could separate the two types of videos. So here you have an example of when we have a lot of movement. This is the heat map and the corresponding histogram with a lot of pixels in between that correspond to these areas. And another example without movement. And with this method, we were able to achieve a 0.98 accuracy. So as a conclusion, with YOLO, we were able to detect the region of interest automatically, achieving pretty good results, and also detecting the cervix even in challenging images. Regarding the movement detection part, we also achieved high results, but we tested our method in a small data set. So the next steps are to test this method with more data, and also integrate the solution to the general pipeline. And regarding YOLO, we're also working with it to detect medical objects, because this would be interesting to advise the doctor in real time to retake the video if some medical images, like if some medical instruments are like on the top of the cervix, because we cannot use these videos. So that's all. Thanks for your attention. And if you have any doubts, please.
Is there any questions from the audience? Okay, yes.
Like for the cervix region detection, we use 650 images, but for the movement detection part, we only use 50 because we had to manually annotate them.
Okay, thank you. Then let's move to the next presentation. The next presenter is